Welcome to this lesson. It's your teacher Agnes, and today we are going to be looking at expansion and contraction of liquids. In the previous lesson, we were looking at how solids expand and contract, and we concluded that when solids are heated, they expand, meaning that they increase in size, and when they are cooled, they contract, meaning that they decrease in size. Now, what do you think happens to liquids when they are heated? Do you think that they also expand, or do you think they contract when heated? What about when they are cooled? Do they expand or do they contract? What if you compare the rate of expansion between liquids and solids? How does it compare? So, if you thought that liquids expand when heated, then you are absolutely right. So liquids expand when heated, okay? And they expand more than solids. So liquids expand more than solids when heated, okay? So if you have a solid and a liquid and you are exposing them to the same amount of heat, then the solid is going to expand more and faster. The liquid is going to expand more and faster than the solid. Now, to demonstrate this, we are going to look at a video of an experiment that is done when water is put in a round bottomed flask and a tube placed at the top, and then we observe how the level of water is going to behave when we heat the flask. Now, after watching the video, you have realized that the level of water in the tube behaves in two different ways. Remember, as you state an observation, you talk about what can you see, what can you smell, or what can you taste. So in this case, we are going to state the observation that we have seen in terms of sight. So when you observe the level of water in the tube, you notice that the level first falls slightly, okay? The level of water in the tube first falls slightly, and then it rises, okay? And then it rises. So why does this happen? Why does the level of water fall slightly and then rise? We already said that when liquids are heated, they expand, they increase in size. So the expectation would have been to observe the level of water rising, but it falls fast. So the reason why the level of water falls slightly, if I draw what we have used in the experiment here, okay, so here we have a round bottomed flask and then we have water in it, all right, then we have the level of water in the tube. Now when we heat the flask, it is the glass of the flask that first comes into contact with the heat. So the glass of the flask is heated first, and when that happens, it expands. That is before the heat gets into the liquid. So when the glass expands, more space is created inside the flask. And because the level of water is still the same, the amount of water is still the same, to occupy the space that has been created as a result of the expansion of the glass, the level of water has to go down. But as heating continues, the heat gets to the water, and the water gets heated, and it expands, and when it does, it expands more than the glass. So the level of the water begins to go up. The more it's heated, the higher the level goes, because as the heat is increased, the expansion of the water also increases. So the reason why the level of water falls slightly is due to the expansion of the glass or of the flask, which creates more space to be occupied by the water. And then the level of water rises because the heat gets to the liquid, which is water, and the water expands more than the flask, and that is why the level goes up. Now you could be asking yourself, what happens if you took the same setup and you cooled it? Okay, if you take the same setup and now instead of heat you have like an iceberg, which is very cold, so the opposite will happen. So if we have this here, okay, this is our tube, we have the level of water, and then in this case now we have an iceberg. So here we have ice. So if we dip this in ice, okay, we dip this flask in ice, we will be reducing the temperature. And if you reduce temperature, then the flask will begin to contract. And when it contracts, the space of the flask is going to be less than it was before. So the level of water will begin to go up, and then it is going to go down. So the level of water is going to rise initially because the flask will contract first, reducing the amount of space that the water is occupying. But the liquid, or rather the water, gets cooled also, and it cools at a faster rate than the flask, and therefore the level of water will now begin to fall continuously. So in this case, the observation is that the level of water rises and then begins to fall. It rises because the flask gets cooled and contracts, reducing the space inside. And then the water begins to cool and cools faster than the flask. And that makes the level of the water to begin falling. So now we can comfortably say that liquids expand when they are heated and they contract when cooled. And the rate at which they expand and contract is higher than when solids expand and contract. However, there is one liquid that behaves abnormally at certain temperatures, and that liquid is water. So we are going to study which is this abnormal behavior. Why is it that at certain temperatures it behaves differently from other liquids? Now we have learned that when liquids are heated, they expand, and when they are cooled, they contract. However, water behaves abnormally, meaning that it behaves in the opposite way when heated between 0 degrees Celsius to 4 degrees Celsius. We expect that, or it is normal, for a liquid to expand when heated between 0 degrees Celsius to 4 degrees Celsius. But that is not what water does. When water is heated from 0 degrees Celsius to 4 degrees Celsius, it contracts, okay, instead of expanding. Now that you agree with me that it is not the norm that we are used to. In the same case, when water is cooled from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, remember, when we cool liquids, they contract. But water, when cooled from 4 degrees Celsius to 0 degrees Celsius, it instead expands, okay? So that is what we refer to as anomalous expansion of water, because it behaves abnormally between 0 degrees Celsius and 4 degrees Celsius. When heated, it contracts. When cooled, it expands. Now, how does that affect the volume and the density of water? But before we discuss that, what happens if you heat water beyond 4 degrees Celsius? If you heat water beyond 4 degrees Celsius to maybe 10, 50, 80 degrees Celsius, water behaves normally like other liquids. So in temperatures above 4 degrees Celsius, water will expand like is the norm with other liquids. And when you cool water below 0 degrees Celsius, it will contract. So it is good to note that the abnormal behavior of water is only between 0 degrees Celsius and 4 degrees Celsius. Beyond 4 degrees Celsius, the behavior is normal, and below 0 degrees Celsius, the behavior is normal. Now, when there is expansion and contraction, there is an effect on the volume and the density of that substance. So, water will have a different density and a different volume between 0 and 4 degrees Celsius. We're going to find out how that is. So, between 0 degrees Celsius to 4 degrees Celsius, when water is heated, instead of expanding, it contracts, okay? So water contracts when heated. Now, if you can remember from our previous lesson, when we were discussing expansion in solids, we agreed that when a substance is heated, it increases in size, meaning that it occupies more space. That means that the volume of that substance increases. So when an object expands, its volume increases. When an object contracts, its volume decreases. So if water contracts between 0 degrees Celsius to 4 degrees Celsius, then it means that the volume will reduce, okay? The volume of water reduces when it is heated between 0 degrees Celsius to 4 degrees Celsius. Now remember that we said that volume and density are inversely proportional, meaning when one increases, the other one decreases. And when one decreases, the other one increases. And it is volume that has an effect on density. So when volume reduces, then the density increases, okay? The density increases. So as we heat water from 0 degrees Celsius to 4 degrees Celsius, it contracts. The volume reduces and the density increases. So it is fair to say that water has the highest density at 4 degrees Celsius, because beyond 4 degrees Celsius, water will begin to expand, okay? When it begins to expand, the volume will increase and the density will decrease. So beyond 4 degrees Celsius, the density begins to decrease. So at 4 degrees Celsius, water has the highest density. Now, when we cool water from 4 degrees Celsius to 0 degrees Celsius, we expect the water to contract, but water behaves in a different way at these temperatures. So it instead expands. So between 4 degrees Celsius to 0 degrees Celsius, water expands. Now when it expands, it occupies more space. So the volume increases. The volume increases. Okay? Now, as the volume increases, what happens to density? Very good. The density decreases. Okay? Because the two are inversely proportional. So as you approach 0 degrees Celsius, the density of water will decrease. So this is why we are saying that water is, has the highest density at 4 degrees Celsius, and then water has the least density at 0 degrees Celsius, because as you approach 0 degrees Celsius, the density decreases. So let me ask you a question. If you have water at 4 degrees Celsius and ice at 0 degrees Celsius, and you put them together in one container, which one will float? Will the ice float or will it sink? The ice will float. I know you have tried this. So the ice will float, and the ice floats because it is less dense than the water at 4 degrees Celsius. So water has the least density at 0 degrees Celsius and the highest density at 4 degrees Celsius. I really need you to remember this, because when we start looking at the effects of anomalous expansion of water in the real world, this is going to be very useful information. Now, this information here about how volume and density is affected by changes in temperature can be represented in a graph, and that is what we are going to look at next. Now, for us to come up with the graphs, we are going to summarize what we have just learned about anomalous expansion of water in this table. So here we have temperatures between 0 degrees Celsius to 4 degrees Celsius. So as we increase the temperature of water from 0 to 4 degrees Celsius, water, instead of expanding, it contracts. So the effect here is contraction. So water contracts when heated between 0 degrees Celsius to 4 degrees Celsius. Now, what about when water is heated above 4 degrees Celsius? So above 4 degrees Celsius, water begins to behave normally. So when heated, it expands, all right? It expands. Now, when water contracts, how does this affect the volume of the water? Contraction means a reduction in size, so water will occupy less space. So the volume will decrease. Now, above 4 degrees Celsius, what will happen to the volume? Now, since water is expanding above 4 degrees Celsius, then the volume will increase, because when expansion occurs, there is increase in size, so water will occupy more space. And remember, volume is the amount of space occupied by matter. Now, effects on density. When volume decreases, the density increases. So here the density will increase, and here the density will decrease. Now I want us to represent this information on a graph, two graphs. In one of the graphs, we're going to have, so we have two graphs here. So along the x-axis, we have temperature in degrees Celsius, and this is 0. Then here we have 4, and let's say here we have 8. Okay. Then along here, we're going to have density. Now the units of density are grams per centimeters cubed. So ensure that as you draw this graph, you label your graph. Okay. Then here we have again temperature along the x-axis in degrees Celsius. Here we have 0, here we have 4, and here we have 8. Then here we have volume in centimeters cubed. All right. So as we begin with, we know that the density of water is not 0, right? And we know that the volume, since we'll be working with a sample of water, it will not be 0. So as we begin to draw a graph, we are going to begin at a higher position. So from 0 to 4, the volume decreases. When it gets to 4, it increases. So from 0 to 4, the volume decreases. When it gets to 4, it increases all the way. So at this particular temperature is where the anomalous expansion of water ceases to happen. It only happens from 0 to 4 degrees Celsius. The volume decreases, and then after 4 degrees Celsius, the volume increases. So I hope this table has made it easier for you to come up with a graph. So next we're going to look at the graph for density. So between 0 and 4 degrees Celsius, the density increases, okay? And then above 4 degrees Celsius, the density decreases. So we're going to start on a higher ground because the density of water is not 0. So as we move from 0 to 4, the density will increase. Then upon reaching 4, the density will decrease. So from here, the density will increase. Then when you get to 4, the density decreases. And then we are able to mark that this shift in the behavior of density happened at 4 degrees Celsius. Okay? So it is important to note, like we have said, that water has the highest density at 4 degrees Celsius and the least volume at 4 degrees Celsius. So now we are going to look at a possible question that can be derived from here. In this question, we have a graph of volume against temperature, and then we can see the curve, and then the temperature here is labeled P. And the question is, find P. So at what temperature does this shift happen? This shift happens at 4 degrees Celsius because we have learned that as you heat water from 0 degrees to 4 degrees Celsius, then it contracts, which means that the volume reduces. But beyond 4 degrees Celsius, the volume increases. So the value of P is 4 degrees Celsius. Now, why was water made that way? It can't have been made, to behave abnormally from other liquids for no reason. So there are 4 effects of anomalous expansion of water in real life, 2 of which are positive and 2 of which are disadvantages. So that is what we are going to explore next. Now, the effects of anomalous expansion of water are 4, and they happen especially when there is formation of ice. So one of the effects of anomalous expansion of water is that it causes freezing or lakes and ponds. Now, there are places around the world that experience the 4 seasons of weather. So during winter, it's very cold. Temperatures can go as low as 0 degrees Celsius and as low as negative. Okay? Temperatures can go below 0 when it is cold in the winter. Now, when that happens, since water freezes at 0 degrees Celsius, so when temperatures go below 0, then there is water that freezes in lakes, and in ponds. Now, when that happens, how do the aquatic animals and the aquatic plants survive during such season? Because I want to imagine where there is ice, fish cannot survive there. It will be trapped in between the ice, and most likely it will die. But that is not what happens. Now remember what we said, that as you cool water from 4 degrees Celsius to 0 degrees Celsius, instead of that water contracting, what it does is that it expands. Okay? That water expands. And when it expands, okay, so I want us to come up with this table. Here we have water at 4 degrees Celsius. Here we have 3 degrees Celsius. Here we have 2 degrees Celsius. And here we have 1 degree Celsius. Then finally we have 0 degrees Celsius. So as you cool water from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, it expands. Now, when it expands, it means that the volume increases. And when volume increases, what happens to density? The density decreases. So, at 4, we have the highest density. And at 0 degrees Celsius, we have the least density. So what happens is that water in the ponds organizes itself or arranges itself such that ice is the one that floats on top because it has the least density. We know that a substance that has less density is the one that floats on top of the one that has high density. So as you can see here, water at 4 degrees Celsius is the one that has the highest density. So if this is a lake, you're going to divide it into 5 layers. Okay, so we have the first layer here, then 2, 3, 4, and then we have 5. So ice has the least density. So what will happen is that the ice will be at the top here at 0 degrees Celsius. That's why we have the ice. And then it will be followed by the water at 1 degree Celsius, which has a relatively low density. So 1 degree Celsius there, then 2 degrees Celsius, 3 degrees Celsius, and finally 4 degrees Celsius. So the water at 4 degrees Celsius is the one that is going to settle at the bottom because at that point, water has the highest density. So when you look at, if you are in a place that experiences freezing, you may be able to see this, in real time. If not, you can watch YouTube videos and you will realize that the ice is always floating on water. So below the ice, there is water. And at the deepest position, we have water at 4 degrees Celsius. And this is where the aquatic plants and the aquatic animals survive. Okay? So this is where the aquatic animals and the aquatic plants survive. Now, their survival would not be possible if water did not behave abnormally. Because if it behaved normally, then when it is cold during winter, all the lakes and the ponds would freeze and the aquatic animals and plants would die. So this is an advantage. It is an advantage that water behaves abnormally because during winter, when the lakes and the ponds freeze, the water at 4 degrees Celsius settles at the bottom and is able to support the aquatic life. Now here is another advantage. When ice is floating at the top, now later as we continue to learn physics, you are going to realize that ice is a poor conductor of heat, meaning that if you have ice here and heat here, the person on the other side will not receive the heat because ice does not pass heat. So this heat that is with the water at 4 degrees Celsius, 3 degrees Celsius will not be passed to the atmosphere because the ice here is acting as an insulator. So there will be enough heat for the animals and the plants that need to survive in the water. So let us look at another effect. Now the second effect of anomalous expansion of water is that it causes bursting of water pipes. Okay, bursting of water pipes. Now again, this happens in regions that experience winter because when temperatures are very low and we have pipes that are transporting water from one place to the other, that ice is likely to freeze. And when that happens, remember we said that when you cool water from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, it expands. And when it expands, the volume increases. Okay? The volume increases. So you see, the pipes have a particular volume that is not going to change with effects in temperature. In fact, when the pipe is cooled, it begins to contract, it begins to reduce in size. At the same time, when water is being cooled from 4 degrees Celsius to 0 degrees Celsius, the water is expanding. So you see, the water now is becoming